We want a Do-more PLC to talk to a GS4 drive over Modbus RTU. To do that, we just wire the Do-more's RS-45 plus signal to the SG plus terminal and the minus signal to the SG minus terminal on the drive. And depending on how your system's set up, you can decide if you need the ground wire or not. If we go to the Do-more system configuration window, we see that the RTU client is built into the Do-more, so all we have to do is select it and make sure these settings match the drive settings. Normally you would change the drive parameters to match the RTU network that the PLC is on. But since we don't have a network set up yet, and since we're here, we'll just change the PLC's parameters to match the drive's defaults. We're not using any transmit control, so that's fine, and we'll leave the RTS signal at follows transmitter. These default values up here are fine. Of course, we need to tell the serial port to use the RS-45 standard, and we'll add the terminating resistor, which you would normally need at both ends of the 45 network cable. Let's have C10 change the frequency to 33 Hz. To do that, we need to communicate with the internal serial port Modbus client that we just set up. The GS4 drive has a node ID of 1, so that's fine. We want to write a single register. Which register? The GS4 uses these registers, which are at these addresses, to control the drive via Modbus RTU. We want to change the speed, that's parameter 926, and we see from the manual that's a decimal address 42331. Do-more Designer adds the 4 for us, so we just put 2331 here and the frequency we want here. Let's copy and paste that rung and use C11 to change the same frequency register to 55 Hz. I'll copy and paste that rung again and have C12 control the forward direction. We need to put the forward direction parameter address here, and forward is a 0. Copy and paste that, and we'll have C13 control the reverse direction, which is the exact same thing, except we send a 1 here. Copy and paste it again, and we'll have C14 control run, which is at this address, and run is a 1. Copy and paste that rung, and we'll have C15 control stop, which is at the same address, but we send a 0. And let's add an end. Let's give each of these control bits a name so they're easier to read in the data view. Oops, looks like I forgot to accept that last change. Great, now we have C15, enter that name, done. Great. Okay, I haven't actually connected to the PLC yet, so let me go ahead and do that. And then we'll go ahead and write this project to the PLC. Let's bring up that data view and add C10 through C14. I've already configured this drive for Modbus RTU. Check out this video to learn how to do that. And it's in remote mode, so it's just waiting for commands. The PLC is running and it's ready. If we activate the 33 Hz instruction, sure enough, the drive changes frequency. If we activate the 55 Hz instruction, the drive reacts accordingly. If we toggle the forward bit and then the run instruction, the motor starts turning and we see that it's in the forward direction. Toggle the reverse contact and the motor changes direction. And if we toggle the stop contact, the motor ramps to a stop. Exactly what we expected. And all we did was wire the two devices together, configure the built-in serial board for Modbus RTU, and made sure it was in RS-45 mode. And then we just issued some MWX instructions. That's all there is to it. Click here to learn more about the GS4 drive. Click here to learn about Automation Direct's free support options, and click here to subscribe to our YouTube channel so you'll be notified when we publish new videos.